With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Good morning, guys. Today we are just going to see a problem. A 50 ml of solution of I2 is divided into two unequal parts. One part with hypo, solution in acidic medium, and 15 ml of 0.4 molar of hypo was consumed. And second part was added with 100 ml of 0.3 molar NaOH. Residual base required to have ml of 0.3 molar H2SO4 solution required for complete neutralization. So they are just asked the initial concentration of my iodine. So let me write the reaction first. So first part, since iodine is divided into two unequal parts, let me write the first part equation. What is the first part is iodine will be reacting with the 2Na2S2O3, that is hypo. I will be giving 2NaI plus Na2S4O6. So I can have 1 mole of iodine here, 2 moles of the hypo be reacting with sodium iodide and Na2SO4O6 as a product. Next step, I am just going to calculate the millimoles of thio, that is Na2S2O3 will be equal to 15 ml that from the data into 0.4 into, I'm just going to calculate for 1 mole of hypo. So what is the value I can have is 6. So from the particular reaction we know that half of the iodine will be consumed for the hypo solution. So I can write the next step, millimoles of iodine used will be equal to half of my millimoles of my Na2S2O3. So I come again. So moles of I2 will be used, will be equal to half of the millimoles of Na2S2O3. So I can divide 6 by 2 here. So I'll be getting 3 as the millimoles of iodine which is used in the first part. And as far as my second part is concerned, let me write the second part. What is the second part here? The second part I will be reacting with NaOH. So let me write the reaction. 3I2 plus 6 NaOH will be giving 5 NaI plus NaIO3 plus 3H2O. So here also I'm just going to calculate the millimoles of H2SO4. Since it is mentioned for complete neutralization, let me calculate the millimoles of H2SO4. So let me take that the millimoles of H2SO4, let the volume of H2SO4, let me take as 10 ml. So I'm just going to substitute here 10 into the concentration of H2SO4 is 3 be equal to from the reaction 2 moles complete neutralization. Since H2SO4 is dibasic, it is a mono one. So 2 is to 1 ratio. I'll be multiplying with 2. So what is that? 6 millimoles are there. So 6 millimoles of H2SO4 is used. And what about my next step? I'll be calculating the moles of millimoles of my NaOH. So millimoles of my excess NaOH will be equal to the same step, the millimoles of my H2SO4. So I can say that both will be same, will be equal to 6 millimoles. This is for NaOH. And what about the next step? I'm just going to write here. The next step is the total NaOH used. So I can write the next step as millimoles of total NaOH. This total NaOH will be equal to my 100, it is given into 0.3 into 1 will be equal to 30 millimoles. So the exact NaOH used will be equal to the exact millimoles, the millimoles of NaOH used for complete neutralization will be equal to NaOH total minus NaOH NaOH of excess. So I can write here the next step is 30 minus 6 will be equal to 24 millimoles, which is exactly used for the complete neutralization. The next thing I'm just going to calculate the total millimoles of iodine which is used in the particular reaction. That is, I'm just going to add these these two things of iodine used. Before that, total moles of iodine used in second part will be equal to, as you know from the reaction, it is half of the millimoles of NaOH. So you can check with your equation, that is we can have a 3 iodine 3 is to 1 here, so 3 and 6 NaOH is here, so 1 mole of I2 will be consuming, it will be having with a 2 NaOH molecule, so I can write that I2 will be equal to half of my NaOH used, so I can write here very well as 24 divided by 2, that is my 12 millimoles. So the iodine used in the second part of the reaction is 12 moles. What about the two parts of iodine here? Total parts of iodine, the total millimoles of iodine used will be equal to part 1 plus part 2 iodine used. What about the part 1 here? Part 1 is 3, I have calculated above, and 3 plus what is here? 12. So therefore altogether 15 millimoles of iodine is used. And what about the next step? I have to calculate the initial concentration, that is molarity of my I2, which is given by the formula millimoles divided by volume. So each everything is represented in milliliter, we can go with that. So 15 divided by 50 ml they have given. So what is the value here is 0.3 molar. So finally we have calculated the concentration of I2 as 0.3 molar. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.